In our next couple of lessons, we're going to be looking at something called simultaneous equations, which is when we have a system of equations or a set of equations that we solve simultaneously, which means at the same time. We're already familiar with how to solve just single equations. So if I had something like 3a minus 1 is equal to 5. And we could solve that already. So we would just undo the operations using inverse operations. So instead of minusing 1, we'll plus 1. And we'd end up with 3a equals 6. And then we'd divide by 3. Whatever we do that side, we'd do this side. 3's would cancel out. And we'd end up with a is equal to 2. We know how to do that. We can solve that one. But we run into issues if we have something with multiple variables. So, for example, if we had 2y plus 4 is equal to, let's say, 4x. So in this case we have y and we have x here. Now we could try and solve it by undoing the operation. So let's say we want to solve and make it so we're going to solve for y. So we could go minus 4 on this side, minus 4 on this side, and I'd end up with 2y is equal to 4x minus 4. And then I could get rid of this 2 again. And so I'd divide by 2 here, and whatever do to that side, I have to do each term in the other side. So I'd have to divide both those terms by 2, and I'd end up with y is equal to 2x minus 2. But I haven't really solved it, and we've seen this before. This is a linear relationship here, and we have multiple solutions that would fit in here. So if x was 1, we'd end up with y being 0. If x is 2, we'd have 2 times 2 minus 2, so y would be 2. And we could put any value for x in and get another value for y. So we don't have just one solution for x and y. We can't solve this equation because it's just a line with infinite solutions. So this is why we need simultaneous equations. So if we have 2 or more equations with the same variables, we can usually find a point where there's one solution for each, one value of x, one value of y. And we call this a system of equations because there's 2 or more equations in the same system. Like if you imagine in the same universe where they've both got x and y, in this case, they could both have m and n or any other amount of letters, but we're going to use x and y because we're going to graph today. So once I've added a second equation here, we now have our system of equations and we can find a point that satisfies both of the equations. So the way we're going to do that is we're going to graph them. So I'm going to graph this one in green. We've got y equals 3x plus 2. 3 is our slope, 2 is our y-intercept. So y-intercept goes here. And let's make x equal to something bigger just so that I have enough things here. If x is equal to 2, I'd have 8. All the way up there. And I'm going to graph that line. So we put our line in through the points like so. And then I'm going to graph this one. Let's graph this other one in, let's go with white. So y equals negative x plus 6, so 6 is our y-intercept. 6, we're going to put a little dot up there. If x is, let's say, 3, negative 3 plus 6 is going to be positive 3. Put another little dot there, and we can graph that line. And what we have here is a point where both those lines meet. And luckily for us, it's a very neat point where they're both integers. So this point here is our point of intersect. And so we can see that point of intersect if we count in. This is x is 1, y is going to be equal to 1, 2, 3, 4, 5. So we've suddenly got a solution here where at the point 1, 5, both these equations are satisfied. And so when x is equal to 1, and y is equal to 5, both of these system of equations has a solution. And the way that we solve it is in these 3 steps. You need to make sure each equation is in slope-intercept form. And that is this form where we have y is equal to mx plus b, if we're going to solve them graphically. So we need this format here. Graph each line and then record the point of intercept. It's just 3 steps. So let's have a look at this system of equations here. So we have y is equal to negative x plus 7. So let's graph that line. Negative x plus 7, it means 7 is going to be our y-intercept. Let's have x is equal to a bigger number, let's say with 5 plus 7. Oh, I've already drawn it earlier. To there, so let's graph that line. Negative x plus 7. We have that line going through there. But if we look at our second line, our second equation, it's not in slope-intercept form. So we need to actually make sure that it is. So the first thing we're going to do is try and solve so we have y is equal to. So I'm going to undo this 4 here, minus 4. And we end up with 2y is equal to 4x minus 4. Make sure that's an equal sign. And then we can divide by 2. Remember, whatever you do to one side, you have to do to each term if we're dividing or multiplying. So we end up with y is equal to 2x minus 2. Much easier to graph there. So 2x minus 2, that means that and I'm going to graph it in red. So if y is equal to our y-intercept, is going to be minus 2, 1, 2. And let's say if I substitute, let's say x is 3, 2 times 3 is 6, minus 2, we've got 4. Oh, that's going to be our point of intercept. So when we draw our line, we can go through those points. I'm just going to have to fix that up a little bit to make sure it goes through our actual intercept there. And we end up with a point of intercept between those 2 lines, right here. So our solution that satisfies these 2 is this point here, and that point is x equals 1, 2, 3, and y equals 1, 2, 3, 4. So at the point 3, 4, both of these equations are satisfied. Both of these equations have a solution. And we can check that. So let's look at this first one here. So if I substitute in to y equals negative x plus 7, they should work out. So if y is equal to 4 and x is equal to 3, I'm going to end up with 4 equals minus 3 plus 7. Oops, sorry. Plus 7. So minus 3 plus 7 is 4. So 4 equals 4. That works. Same thing with this one. If y is equal to 4, so 4, let's move this on over here. 4 equals 2 times 3 minus 2. I'd end up with 4 is equal to 6 minus 2. 4 equals 4. And this one works. So this becomes our solution. This point here. So when x is equal to 3 and y is equal to 4, we have a solution to this system of equations, that point of intersect there. Now there is one problem when there is no solutions, not really a problem, but there is one situation when there is no solutions, and that is when you have parallel lines. So if we have the same gradient, so if we had y is equal to 2x minus 1 or y is equal to 2x plus, doesn't even matter what, we have the same gradient here, so they're parallel, they're never going to meet, so they're never going to have a solution. And that is the one key thing to remember. If you come across parallel lines in a system of equation, there's no solution. Thank you.